and Assalamualaikum. In this video, our group are going to present about the application of differentiation, which is applied maximum and minimums problems. As we know, there are 5 subtopics in this chapter, which is related rates, analysis of function 1, analysis of function 2, applied maximum and minimums problems, and the last one is Rolle's theorems and mean value theorems. Now, I'm going to talk about the meaning of differentiation. Differentiation is a method used to compute the rate of change of a function fx with the respect to its input x. There are also a few rules that we can use to solve the differentiation equation, which is first, the derivative of sum and difference. Second, the product rules. The rules that we use to find the derivative of a product function. And the last one is the quotient rules. The rules that we use to find the derivative of a rational function. So what are the meaning of maximum and minimum? In mathematical analysis, the maximum and minimums of a function are respectively the largest and the smallest value taken by the function. In calculus, there is two rules of applied maximum and minimums problems. First, if f prime x function change sign from positive to negative as x increases through point C, then point C is the point of local maximum and the fc is the maximum value. Second, if f prime x function change sign from negative to positive as x increases through point C, then C is the point of local minimum and the FC is the minimum value. How to solve the maximum and minimums problems? To solve the maximum and minimums problems, it requires 3 steps. First, find the derivative. Second, let the derivative equal to 0 and find the value and variables. Third, do the second derivative test. If second derivative test less than 0, it is a maximum value. If second derivative test greater than 0, it is a minimum value.
Here is the problem statement.
The solution for question A, express h in terms of x. Firstly, we need to apply the parameter formula. The value parameter that has been given in the question is parameter is equal to 4. So we just insert the value into the equation. It will be x plus h plus 2 pi r over 2 equals to 4. After that, we will get a new equation, x plus 2h plus pi r equals to 4. Since r is radius, but the question only gives diameter as x, we change the pi r into pi times width x over 2. It will be x plus 2h plus pi x over 2. Then we move x and pi x over 2 to the right so that we only have 2h on the left. After that, since we had pi x over 2, we need to multiply 4 and x with 2 over 2 so that we can equalize the denominator. In addition, we will get 2h equals 8 over 2 minus 2x over 2 minus pi x over 2. Since all denominator are the same, we can write it as 8 minus 2x minus pi x divided by 2. After that, we move 2 from h to the right. It will be divided. Finally, we will get h equals to 8 minus 2x minus pi x over 4.
First, let out the area of the rectangle and the semicircle. A equal to x multiplied by h plus 1 over 2 pi x over 2 squared. Then we expand the x over 2 square. We got A equal to x multiplied by h plus 1 over 2 pi x squared over 4. Then we multiply the 1 over 2 with the x squared over 4. We got a equal to x multiplied by h plus 1 over 8 pi x squared. Then we got a equal to x multiplied by 8 minus 2x minus pi x over 4 plus 1 over 8 pi x squared. Then a equal to 8x minus 2x squared minus pi x squared over 4 plus 1 over 8 pi x squared. After that, we multiply the 8x minus 2x squared minus pi x squared over 4 with 2. Then we got a equal to 16x minus 4x squared minus 2 pi x squared over 8 plus 1 over 8 pi x squared. After that, we simplify it. Then we got a equal to 16x minus 4x squared minus 2 pi x squared plus pi x squared over x. Lastly, we got a equal to 16x minus 4x squared minus pi x squared over 8.
So in question C, the answer is using the apply maximum and minimum problems. To answer these questions, firstly, we need to find the derivative of the function a, which is a equal to 16x minus 4x squared minus pi x squared over 8. Then, let the derivative equal to 0 and find the values of the variables. Lastly, to know if either the answer is maximum or minimum value, do a second derivative for the functions. Then, test if the second derivative that we got is less or more than 0. Here is the calculation for the question C. Step 1. We simplify the function that we got from the question B. Then we're gonna have a equal to 2x minus 1 half x squared minus 1 over 8 by x squared. Then differentiate the function. Then we got dA over dx is equal to 2 minus x minus 1 quarter by x. For the second step, let the derivative of the function equal to 0. Before that, we simplify the functions by factorizing the negative x minus 1 quarter by x. So there will be 2 minus x in the bracket 1 plus 1 quarter pi equal to 0. Then bring the negative x in the bracket 1 plus 1 quarter pi to the right side. As we know, we are finding the value of x, so bringing the 1 plus 1 quarter pi to the left side, then it will turn to 2 divided by 1 plus 1 quarter pi. Then use the calculator to find the answer. The answer that we got is x equal to 1.12 meter square, and that will be the area of the window. The questions have mentioned that the area is the maximum value. So to know is either correct or not, we proceed to the third step, which we have to find the second derivative of the function. So differentiate the dA over dx equal to 2 minus x minus 1 quarter by x. So then we will get d squared a over dx squared equal to negative 1 minus 1 quarter. Then we simplify and we will get negative 5 over 4. As we know, negative 5 over 4 is less than 0, so it means the value is maximum.
In conclusion, by applying the maximum and minimum problem methods to this problem, we can conclude that the application of this method can be used to find a value of volume, can determine the minimum and maximum area, and can solve problems that related to the value of a volume.